Yep. All right, we're going to go over the slope field homework question that I assigned. So here's the slope field. I did this ahead of time so you didn't have to watch me crunch numbers. You will notice a few things. You'll notice that there are no slopes drawn on the x-axis. These are tick marks. So in other words, like this is just 1, 2, 3, -1, -2, -3. I didn't draw any red slopes there, because technically the slopes would be undefined there. So in other words, if I looked at this point right here, and I'll actually label it 3, 0, and now I evaluate dy dx at that point 3, 0, right? This is my x, this is my y. I chuck it into your slope field, you're going to get -3/0. That's not defined. So I did not draw any slopes there. If you do this on GeoGebra, I believe it's going to draw vertical lines there because the slopes, in fact, would be vertical. But we're not going to draw any because technically it's undefined and, it's kind of semantics. There would be vertical slopes here on the actual general solution, but I like doing this, and maybe I'll tell you why in a second. All right. The other thing is to hopefully understand how I'm getting these slopes, right? I just did the one at 3, 0. If I did the one, say, at 1, 1, so I'll label this point 1, 1, right? What are you doing? You're just evaluating the point in the differential equation. So you're taking dy dx and you're chucking 1, 1 in it. So it'd be -1/1. That's -1. So right here, I'm drawing a short line segment indicating a slope of -1. So in other words, this little slope here, the direction of this guy should be pointing down 1/1. So I did a good job of this is pointing right here, which it looks like it is. If I had the opposite direction, or maybe it was pointing somewhere really egregious, then you wouldn't get credit for that. All right, take a look at, we'll pick another point. Let's pick this point right here. So this would be -2, 2, right? So -2, 2. So dy dx evaluated at the point -2, 2. So negative x, so -2/2, that's going to be +1. So the point right here, this slope, this little short line segment should be pointing to up 1/1, and it looks like it is. So I'm not going to do that for every single point, but that's what I did. I'm just not going to show you that for every single point. But that's what you have to do. And you'll kind of notice a little pattern here on the diagonal going out this way. The slopes are the same and whatnot. These were easy to do, right? Because here, the y values are all differing, but the x value is 0. So 0 over anything other than 0 would be 0. So you get the idea. So this is the slope field. All right, so again, what am I looking at? What is the slope field? The slope field is basically a visual of what those family of functions differing by a constant are going to be. And if you look at that, what does it look like those family of functions would be? In fact, maybe I should really say family of relations, right? And it looks like you'd have circles here, right? If I was to kind of like sketch something in, you'd have a circle. So now, all right, let's go ahead and let's do the second part of this question, which is go ahead and solve this. So the only way we know how to solve differential equations is separation of variables, right? So remember how we do this. Since the dy is up top over here, I got to bring the y's over. So I would multiply both sides by y. So I would get y dy. And then over here, this dx is in the basement, no bueno. Multiply both sides by dx, I get -x dx. I now have separated my variables. More importantly, the dy and the dx are connected with multiplication, which means that both the left side and the right side are in a Riemann integrable form. So I get the green light to integrate both sides. So if I integrate y, I get 1/2 y squared. And if I integrate -x, I get -1/2 x squared. And some of you on the last homework question stopped there. And as I have been saying, you would get hammered by the AP grading police because what did you forget? You forgot that constant of integration. So when we do an indefinite integral, you got to have that constant of integration. Technically, you should be adding it to both sides of this equation. But think about it. If you're adding a constant to the left side and you're adding a constant to the right side, and eventually you want to solve for y, you're just going to subtract this constant over. So we kind of like bypass that step, and we just add the constant to one side. And I would add it away from what you're solving for. Since I wanted to solve for y here, those were the directions, then I'm going to add it to this side. And now we just have to spruce this up. So maybe the first thing to do here is to multiply both sides by 2. So if I do that, I get y squared equals -x squared plus 2c. And I can write 2c, but you know what? At the end of the day, 2c is just a constant. So I'm just going to write k. And you could write 2C, and you probably could get away with just writing C again. But since C is kind of defined in this line, I like to change it. So either write 2C or change up the letter. And now I'm going to solve. So how do I solve for y here? So I'm going to square root both sides. But you got to remember, when the square root principle, when you square root both sides away from that variable, technically you have to do what? You have to do plus or minus radical, and maybe I'll rearrange this, k minus x squared. Okay, so this is your family of functions differing by a constant that satisfies this differential equation. Now, I say functions here because there's kind of two answers. There's the plus radical and there's the minus radical. So seen separately, each one is a function. The plus radical, hopefully you recognize this, would be the upper portion of a semicircle, and the minus radical would be the lower portion of the semicircle. So together they're a relation, they're not a function, but seen separately, they're what we can say are implied functions. So now the next part of this question said, go ahead and sketch in the particular solution that goes through the point, I think I said 2, 1. So 2, 1 is this point here. So I want to sketch in the solution. So I kind of want to follow the streams here. So if I did that, I'm going to do this by freehand on this pad. That was horrible. All right, let me try. I got to give one more shot at that. That was terrible. All right, it looks like that was a little bit better. I get something like that. Now notice what I did not do, okay? I did not change the color. I did not do that. I did not make the complete circle, as some of you may have. And I said most of you, or 50% of you, I think I said, might get it wrong. You can't do that. And you're like, well, why? It's a circle. Well, it's kind of the same idea when you're finding the domain, right? When you're sketching in your particular solution, you can never jump a spot where a slope is not defined, all right? It's not really giving you the most mathy of reasons why, but here the slope is not defined, right? So I cannot jump that spot right there because there is no slope there. So you have to stop. So you only sketch, in this case, this upper branch. So it's the plus version that you see here. So now if the next part of this question was go ahead and find the particular solution, right? So you're like, all right, how do I find the particular solution? So you're given the initial value 2, 1. That's an x, that's a y. Chuck it in here. So you're going to get 1 goes in for the y, and then, which one do you pick? You have to pick the plus. K minus 2 squared. You're like, well, how do you have to pick the plus? Well, because you have to know that the point 2, 1 is on the plus branch. That's why you pick it. Obviously, if you pick -2, this would have to be a negative y value, which it is not. So when I solve this now, right, what would I do? I'd square both sides. So this would be 1. This would be k minus 4. You square the radical, it goes away. Add the 4 over, and I end up getting that k equals 5. Put it all together. Y equals, in fact, why don't I do this in blue? Y equals the positive, and I'm not going to emphasize the positive by putting positive. I'm just going to say principal square root of 5 minus k squared. All right, this would be your particular solution that we actually sketched, right? This is right there. That's the particular solution. Whereas this was the what? This was your general solution. This is basically looking at the slope field and getting an idea of what those family of curves are going to look like. Okay? And yeah, again, we should recognize this. Maybe the 5 is freaking you out. Normally this is like a 9 or a 16. It's a perfect square, right? And so we know that, oh yeah, this is the upper portion of a semicircle where this represents r squared. So the radius here would be radical 5. And if I look at this circle, it looks like the radius would be radical 5, right? A little bit more than 2. The square root of 5, square root of 4 is 2, square root of 5 a little bit more. So that kind of makes sense. And so that's what you got going on there. So this is a great, solid question. This is a typical AP type question. Where they would give you a much smaller slope field because, again, it is tedious, where you have to put in the slopes, then you have to solve the equation, then maybe find a particular solution, then maybe sketch in a particular solution. I would just make a note here. I'm not going to write this out because it would take forever, but you should write this out and take in your notes. Note, right? This is what the really good student would do. When sketching a particular solution, do not jump a spot where the slopes are not defined, and then you'll be good to go. And usually what you'll see is you're going to find yourself on one branch of either a relation where they're implied in functions, or one branch of a function where maybe they're separated by an asymptote, which we saw in an earlier question. All right, so hopefully you crushed that. 1 week is done. That was all new material, guys. I don't think it was too bad. Monday I'm going to do one sort of new thing, not really, and then that's it. You have learned everything that is in the AB calculus curriculum. All right, so you basically only had 1 week out of school that you had to learn. So I feel pretty good about that. You should feel pretty good about that. We'll start getting into talking about your AP test next week. Your AP test is going to be modified, as I'm sure you know. More information is going to come out on April 3rd, so that's why I'm kind of holding off on giving you the details. But basically, it's going to be a shorter test. It's going to be a test that somehow you can possibly take at home. And the unit that we did on area and volume, the unit right before we went out, is actually not going to be tested, which I think kind of stinks because I like that unit, but you might be happy about that. But this stuff will be. So differential equations will be on it, just because of the order in which, the AP College Board decided to go through it. All right, so I hope everyone's safe. Be good. Have a great Friday. Looks like the sun is coming out. Go out, go for a run. Just stay 7 feet away from people. Give it that extra foot. All right, be good. Peace out, Cub Scout.